All right, welcome back. Another week. It's week 6 of quarter 3, and we're going to talk about a third way we have to solve quadratic equations, and that is by using the square root property. And the square root property is really something that you already know. It's just you're going to need to be reminded of something about it, and that's what we're going to do right away here. So a little reminder about square roots. So if we look at these three things we have here in front of us, we know that the square root of 9 is equal to 3. And earlier in the year, we talked about square roots and said we have to be told when the square root of 9 is negative 3. So, because we know that 9 is equal to 3 times 3, but it's also equal to negative 3 times negative 3. So I guess technically it could be 3 or negative 3. But with square roots, we always assume that if it's just the square root symbol or the radical symbol, we assume it's the positive. And we have to be told if it's the negative. So the second example is we're being told it's negative because it has a negative sign out front. So we know that this one is negative 3. And then something that we always tend to forget is that if we have x squared is equal to 9, this is one where if we take the square root of both sides, x is equal to both the positive and the negative 9. And so that may seem, not 9, I meant 3. So that might seem kind of weird considering what we just said, where the square root of 9 is 3, the negative square root of 9 is negative 3. Well, here we just have square root of 9. We're not being told it's negative, right? But there's another way to think about this one. We can think about it as a quadratic equation. If we take x squared equals 9, and we just subtract 9 from both sides. If we subtract 9 from both sides, we get x squared minus 9 equals 0, and we should recognize that that is a quadratic equation. It's got a squared term, but it's missing the x term, which is okay. The other thing we should notice is that this is a perfect square. And x squared is a perfect square, 9 is a perfect square, but we have the difference between them. So technically it's a difference of squares, and so we can rewrite this as two binomials, x plus 3 times x minus 3 equals 0. So now this is where we get the positive and the negative 3 from. We can say, all right, the solution to the first binomial is going to be negative 3. The solution to the second binomial is going to be positive 3. So that is why x squared equals 9 means x is either positive 3 or negative 3. All right, and that's the thing that we need to remember. And when we're using the square root property to solve a quadratic equation, it's a fairly simple process. We just want to make sure we can isolate the squared term in the equation and then take the square root of both sides, just like we did with x squared equals 9, and simplify. But the important thing is we have to think about it as the plus and minus. We can't just think about it as the positive. And then the last step, it says there, if necessary, solve two equations, one for the positive value and one for the negative value. So you'll see what I mean. A bunch of these you will not have to solve two equations because there will be nothing left to solve. But some of these you're going to have to solve two equations, and so I'll show you what I mean by that. All right, so if we look at this first one, 5x squared equals 240. Technically, it's a quadratic equation. It's just not equal to 0. We could make it equal to 0 if we wanted to, but that would only make our life much harder. So what we want to do is just isolate the x squared if we can. And so the way we can isolate the x squared here is we can just divide everything by 5, right? We can get rid of the 5 by dividing by it. So we have x squared equals, what would that be? 400, or 48, not 400. So 48, because 5 times 48 is 240. And then all we have to do is take the square root of both sides. So we have x squared equals 48, and we're going to take the square root of both sides. So that means x is equal to plus or minus the square root of 48. Okay? We don't have an equation to solve now. So technically, we don't need to do this step right here. However, we do have a radical that we need to simplify. So the square root of 48 can be written as the square root of 16 times the square root of 3. And so we can simplify that to 4 times the square root of 3. And the thing we really don't want to forget is what we just talked about in the opening, where we have to think about the positive and the negative. So there are two answers here. One is positive 4 times the square root of 3, and the other one is negative 4 times the square root of 3. Okay, so there are the two solutions to that quadratic equation, and we found it by using the square root property. Okay, and this will work for any quadratic equation where you can isolate the squared term. All right, now if you had an x term in an equation of some sort, it's going to be really hard to isolate that. So you want to be careful when you're looking at a quadratic equation. This isn't going to work with all of them. It's only going to work with some of them. So, and it's definitely easier than using the quadratic formula. So if you can recognize these and be able to do them, that will make your life a lot easier. All right. So the first one, we just had to divide by 5. This one, we have x squared plus 5. So the way we're going to isolate the squared term is we're just going to subtract 5 from both sides. So we subtract 5. We end up with x squared equals 162. And then we just simply take the square root of both sides. So we have x squared equals 162. Take the square root. So x equals plus or minus the square root of 162. All right, again, we don't have anything to solve here. So there's not two equations that we have to solve. All we have to do is simplify that radical if possible. All right, and it is something that we can simplify. And so maybe the thing we should do is come over here to the right and maybe make a quick little list. So 162 can be 1 and 162. 2 and 81. All right, that 81 is something that can be simplified, right? Because 81 is 9 times 9. So we could write this as 81 times, or the square root of 81 times the square root of 2, right? So we could say, all right, this is, I'm going to write the plus or minus this time. I forgot to do it last time, but it still worked out. So we have square root of 81 times the square root of 2, and then we can simplify that first one. So our answer is plus or minus 9 times the square root of 2. All right, so not too bad. It's pretty easy if you are able to isolate that squared term, and then if you're able to simplify a radical. So the last one, it has something that looks a bit different. So our squared term is actually a squared binomial. And what we can do is we don't have to do anything to isolate this binomial, or this squared term, because it's already squared. Okay, so in this case, we don't need to isolate because it's already isolated. All we have to do now is take the square root of both sides. And you might think, well, if I take the square root of that, aren't I going to have a big old mess? And no, because the binomial is just like x. It's just one thing. Even though there's multiple things inside that binomial, it's one thing. And so when we take the square root of it, we just get that binomial out by itself. And I didn't include the parentheses because I don't need to include the parentheses. So, and then we have the square root of 16 here. So, and this is one where we got to be really careful. We might be tempted to write this as x minus 3 equals 4 because the square root of 16 is 4, but we have to remember it's plus or minus 4. And we are going to have two answers to a lot of our quadratic equations. So the plus or minus gives us our two answers. All right, so this one, we actually have to solve two equations because we have x minus 3 equals positive 4. and we can solve that and say x is equal to 7, right? And then we have x minus 3 equals negative 4. And if we solve that, we have x is equal to negative 1. So there we have our two solutions. And in this case, they are two unique numbers, whereas the other two examples, they looked exactly the same. One was positive and one was negative. All right, so just like last week, the way this assignment works is you got a whole bunch of problems here that you need to do, and you're going to have to submit this in Schoology on the assignment. So this won't be actually attached to the assignment in Schoology. You're going to have to use this page here. All right, if you have any questions, struggling with anything, please let me know and I'll help you out.